This is section 11.1 part B, the chi-square distributions and p-values. We used Fathom software to simulate taking 500 random samples of the size 60 from the population distribution of M&M milk chocolate candies from the Mars Incorporated. The dot plot below shows the values of the chi-square statistic for these 500 samples. The blue vertical line is plotted at the observed results of chi-square equals 10.180. Recall that larger values of the chi-square give more convincing evidence against the null hypothesis. According to Fathom, 37 of the 500 simulated samples results in a chi-square statistic of 10.180 or higher. Our estimated p-value is 37 out of the 500, which is 0.074. Since this p-value exceeds the default alpha equals 0.05 significance level, we do not have enough evidence to refute the company's claim about the color distribution. As the previous dot plot suggests, the sampling distribution of the chi-square statistic is not a normal distribution. It is a right-skewed distribution that allows only positive values because chi-square can never be negative. The sampling distribution of chi-square differs depending on the number of possible values for the categorical variable, that is, on the number of categories. When the expected counts are all at least 5, the sampling distribution of chi-square statistic is close to a chi-square distribution with degrees of freedom equal to the number of categories minus 1. As with the t-distributions, there is a different chi-square distribution for each possible values of the degrees of freedom. The chi-square distributions are a family of distributions that take only positive values and are skewed to the right. A particular chi-square distribution is specified by giving its degrees of freedom. The chi-square goodness of fit test uses the chi-square distribution with degrees of freedom equal to the number of categories minus 1. The above figure shows the density curve of 3 members of the chi-square family of distributions. As the degrees of freedom increases, the density curve becomes less skewed, and larger values become more plausible. Here are 2 other interesting facts about the chi-square distribution. The mean of a particular chi-square distribution is equal to its degrees of freedom. For degrees of freedom greater than 2, the mode, or the peak, of the chi-square density curve is at the degrees of freedom minus 2. So when the degrees of freedom is 8, for example, the chi-square distribution has a mean of 8 and a mode of 6. To get p-values for the chi-square distribution, we can use Table C in your packet of tables, or you can use technology. The following example shows how to use the table. In the last example, we computed the chi-square statistic for Jerome's random sample of 60 M&Ms to be chi-square equals 10.108. Now let's find the p-value. Because all the expected counts are at least 5, the chi-square statistic will follow a chi-square distribution reasonably well when the null hypothesis is true. There are 6 color categories for the M&M milk chocolates, so the degrees of freedom will be 6 minus 1, which equals 5. The p-value is the probability of getting a value of chi-square as large or larger than 10.180 when the null hypothesis is true. The below figure shows this probability as an area under the chi-square density curve with degrees of freedom of 5. To find the p-value using Table C, look at the degrees of freedom of 5 row. The value of chi-square of 10.180 falls between the critical values of 9.24 and 11.07. So if you look at the top of those columns, the corresponding areas to the right tail for the chi-square distribution with degrees of freedom of 5 will fall between 0.10 and 0.05. So that p-value for the test based on Jerome's data is between 0.05 and 0.10. Based on Jerome's sample, what conclusion can we draw about the null hypothesis that the company's state color distributions for the M&M milk chocolate candies is correct. Since our p-value is between 0.05 and 0.10, then this p-value is greater than the alpha equals 0.05 significance level. So we will fail to reject the null hypothesis. We do not have sufficient evidence to conclude that the company's claimed color distribution is incorrect. So let's check our understanding. We're going to go back to those peanut chocolate candies from M&M's, and we know that 23% are supposed to be blue and orange, 15% are supposed to be green and yellow, and 12% are supposed to each be red and brown. Joey bought a bag of peanut M&M candies, and the counts were 12 blue, 7 orange, 13 green, 4 yellow, 8 red, and 2 brown. Confirm that the expected counts are large enough to use a chi-square distribution. Which distribution specify the degrees of freedom should you use? So first you're going to find the expected counts for each of these, and remember each of them should be at least 5. So if we find our expected values again, to do that you're just going to take your sample size, which in this case is 46, and you're going to multiply it by the percent that we would expect of that color. So for brown it's 12%, so we would do 0.12 times 46, which gives us 5.52. We're going to do that for every color, and since all the expected values are at least 5, we can do a chi-square distribution. Now our chi-square distribution for this problem should use a degrees of freedom of 6 minus 1, which equals 5, since there are 6 different color categories. Sketch a graph like the figure in the previous example to show the p-value. So this is going to be skewed to the right. And in the examples we did in the last section, we found a chi-square value of 11.3724. So we would have our graph, and we would have our value of 11.3724 on the graph. Now we're going to use the table to find the p-value. Now if you look at your table C, you are going to look for degrees of freedom of 5, and you're going to go across the row until you find where 11.3724 would lie. Now this value is going to fall between 11.07 and 12.83. So if you look at the top of those columns, you will see that our p-value is going to fall between 0.025 and 0.05. What conclusion would you draw about the company's claimed color distribution for the M&M peanut chocolate candies, and justify your answer? Since the p-value is less than 0.05, we reject the null hypothesis and conclude that at least one of the proportions of M&M peanut chocolate candies of this particular color is different from what the company reported.